Hello. I'm covering section 1.6. I'm starting this. This is a long section, so I will cover this in 2 videos. So I'm starting with 1.6, other types of equations and applications. That's going to be the first. I'm covering the first part today. Well, or I'm covering the first part in this video. Okay, so in this section, we study equations can be solved or that lead to linear or quadratic equations. Such as rational equations, radical equations, and equations in quadratic form. Or I'm just going to say other equations in quadratic form. Okay, so we're starting with rational equations. A rational equation is an equation that contains variables in the denominator. Okay, here's an example. We're going to solve the equation. X over x plus 2. Let me copy this. So that's x. I'm trying to get this to work. Okay, there it is. So that's going to be x over x plus 2 plus 2 over x squared plus 5x plus 6 equals 5 over x plus 3. The strategy for this type of equations, is by using the least common denominator. So we're going to multiply both sides of the equation by the least common denominator. Okay, we know that x squared plus 5x plus 6 can be factored as x plus 2 times x plus 3. Okay, so the denominators are x plus 2. These are x plus 2, x plus 2 times x plus 3, and x plus 3. So the least common denominator is x plus 2 times x plus 3. And we're going to multiply the original equation by the least common denominator. So that becomes either a linear or a quadratic equation. So we're going to multiply the LCD, the least common denominator, to both sides of the equation. Okay. So left-hand side, x plus 2 times x plus 3 times x over x plus 2. So in the first case, we cancel the x plus 2's. So we cancel this 2, and we have x times x plus 3. Plus 2 times, or x plus 2 times x plus 3 plus 2 divided by x squared plus 5x plus 6. Well, at the end, they are the same thing. Then the least common denominator and the denominator of the second expression are the same. So that's going to be plus 2. And then x plus 2 times x plus 3 times 5 over x plus 3. So these two cancel out. And in the other case, these two canceled out. And we have 5 times x plus 2. Okay, so we no longer have variables in the denominator. This equation became a quadratic equation. We're going to write the equation in standard form. First, distribute the x and the 5, and then write in standard form. That's going to be x squared. Then plus 3x minus 5x is going to be minus 2x. Plus 2 minus 10 is going to be minus 8. Okay, so this quadratic equation factors as x minus 4 times x plus 2. And the solution of the resulting quadratic equations are 4 and 2. But we are not done yet. We're not done yet because this is a resulting quadratic equation, but the equation we began with was the rational equation. And if you notice, if we try to plug in -2 into the original equation, we're going to have division by 0, which is undefined. So we're not done yet. These are only the possible solutions. We still need to check. So the above or the numbers, -2 and 4, are possible solutions. But we're not done yet. We need to check. We check them in the original equation. Okay, so let's check -2. Okay, we check -2. We have what? We have, let's plug it in. So we have the equation there. That's going to be -2 over -2 plus 2. And then plus, I'm just going to keep it in factor form, plus 2 over -2 plus 2 over 3 over -2 plus 3. That's supposed to be equal to 5 over -2 plus 3. The problem is that we have -2 over 0, and we have another 2 over 0, or 0 times 1. So this is false. This is false because division by 0 is undefined. So -2 is not a solution. The above is false because division by 0 is undefined. Okay, and we're going to check for. It may happen that only one is a solution or both are solutions, or in some cases, none of them is a solution. So let's check for. We have 4 over 4 plus 2. Plus 2 times, or 2 divided by 4 plus 2, 4 plus 3, equals 5 over 4 plus 3. Okay, so 4 over 4 plus 2 is 4 over 6. 2 over 4 times 2 times 4 plus 2 times 4 plus 3, that's going to be 4. That's going to be 4. That's going to be 2 over 6 times 7. Equals 5 over 4 plus 3. Or 5 over 7. So that's 2 over 3. And then we can reduce to 6 as 1/3. So this is 1 over 21 equals 5 over 7. So 2 over 3 plus 1 over 21 is going to be common denominator is 21. So that's what? That's 14 plus 1 equals 5 over 7. But 14 plus 1, I'm just going to write on the side. That's 15 over 21 equals 5 over 7. And indeed, we can reduce this fraction as 5 over 7. So this is true. Okay. So we started with a rational equation by multiplying the least common denominator to both sides. We obtain a quadratic equation. The quadratic equation had 2 solutions, -2 and 4, but only one is a solution of the rational equation. And at the end, the solution set is 4. So it's important to check when you have other types of equations. It is very important to check. Next example, I'm going to do a second example. Let's see. Well, I will do 2 more examples. So this one, the first I did, only had 1 solution. Let's check the next one. Number 2. We are going to solve the rational equation 3 over x plus 2 minus 1 over x equals 1 over 5x. Okay, so the denominators are x, 5x, and x plus 2. The least common denominator of x plus 2, and 5x is going to be 5 times x plus 2. Okay, we're going to multiply the least common denominator to both sides of the equation. So this is the least common denominator. We're going to multiply it to both sides. Okay, so 5x times x plus 2 times 3 over x plus 2. The x plus 2's cancel out, and we have 5x times 3. Minus 5x times x plus 2 times 1 over x. The x is cancel out, and we have 5 times x plus 2. And then 5x times x plus 2 times 1 over 5x. The 5x cancel out, and we have x plus 2. We ended up with a linear equation that we are going to solve. So that linear equation is going to have one solution. Most likely it's going to have one solution, but the solution of the linear equation may not be a solution of the rational equation. So we need to check it. But let's solve the linear equation. Okay, so we're going to solve the linear equation. Next, let's simplify. So that's 10x minus 10 equals x plus 2. And then subtract x from both sides. We have 9x. And add a 12 to both sides. We have 12. Or add 10 to both sides, we have 12. So x, it's 12 over 9. Or reducing the fraction is 4 over 3. Now, this is only a solution of the resulting linear equation. We still need to check whether this is a solution of the rational equation. Okay, we plug it into the original equation. We have 3 over 4 thirds plus 2 minus 1 over 4 thirds equals 3 over so that's okay. Let me check. So that's 3 over x plus 2, and then 1 over 4 thirds, and then sorry, that was a 1 equals 1 over 5 times 4 thirds. Okay, so let's check it. 4 thirds plus 2, that's 4 thirds plus 6 thirds, so that's 3 over 10 thirds. Minus 1 over 4 thirds is 3 fourths. And then 1 over 5 times 4 thirds is going to be 20 thirds. Okay, so 3 times 10 thirds, that's going to be 3 times 3 over 10. Minus 3 fourths equals 10 over equals 3 over 20. Okay, so that's the right hand side. That's as much as we can simplify. The left hand side, that's going to be common denominator, it's 20. That's the least common multiple of 10 and 4. And then we have 18 minus 15. So indeed, 18 minus 15 is 3. So that is a solution. So the solution set is 4 thirds. Okay, now we'll do one more example. So the first example resulted in a quadratic equation, and there was only one solution. So there might be one solution or two solutions or no solution. So I'll do a third example. We're going to solve. Uh, 4 over x plus 1 minus 3 over x plus 2 equals 1. So the least common denominator is x plus 1 times x plus 2. Yeah, we're going to multiply that on both sides. Okay, so we're multiplying the LCD to the left side, and we're going to multiply this to the right side. Okay, so left-hand side. X plus 1 times x plus 2 times 4 over x plus 1 is going to be 4 times x plus 2. Minus x plus 1 times x plus 2 times 3 over x plus 2. We have 3 times x plus 1. X plus 1 times x plus 2 times 1 is going to be x squared plus 3x plus 2. Okay, we have a quadratic equation. We're going to simplify that. Okay, we're going to simplify and then combine like terms. We have x plus 5. We have this. And let's write the equation in standard form. X squared plus 3x minus x is x squared plus 2x. And 2 minus 5 is -3. So that's the equation in standard form. We're going to solve this by factoring. That will factor as x plus 3, x minus 1. So the possible solutions are -3 and 1. But we're not done yet. We need to check them. There are definitely solutions of the resulting quadratic equation, but we need to check them in the rational equation. Okay, so if we check -3, we have 4 over -3 plus 1 minus 3 over -3 plus 2 equals 1. So that's 4 over -2 minus 3 over -1. Or -2 plus 3 equals 1. So 1 equals 1. This is true. And -3 is a solution. And finally, we're going to check 1. So that's 4 over 1 plus 1 minus 3 over 1 plus 2 equals 1. So this is 4 over 2 minus 3 over 3 equals 1. But 4 over 2 is 2. So this is 2 minus 1 equals 1. So 1 equals 1. This is also true. So both ended up being solutions. The solution set is -3, 1. Okay, and I'm going to do 2 examples. I'm going to do an application of rational equations. So it's an application is to work rate problems. Okay, so here's the situation. If a job can be completed in 3 hours, then the rate of work is 1/3 of the job per hour. After 1 hour, the job would be 1/3 complete. After 2 hours, the job would be 2/3 complete, 2/3 complete. In 3 hours, the job would be 3/3 complete, meaning that one complete job has been accomplished. Okay, so if a job can be completed in k hours, so if you know that a job can be completed in k hours, the rate R is 1/k. Okay, so the rate R is 1/k, and that would be per hour. So in 1 hour, that fraction of the work will be completed. After 2 hours, it's going to be 2/k. After 3 hours, 3/k, and so on and so forth. So after k hours, k/k, or one whole job will be completed. So that's the rate, and A equals R times T is the amount completed after T hours. Is the amount of work, or the part of the job, or portion of the job completed after T hours. So at the end, the amount of work is going to be the rate of work times the amount of time worked. Okay, we're going to do number 37 on page 147. So this on page 147. This problem appears in the 1994 movie Little Big League. If Joe can paint a house in 3 hours and Sam can paint the same house in 5 hours, how long does it take them to do it together? If they combine their efforts, it's going to take them. They are going to do it faster, but how long is it going to take them? Okay, so we know that Joe can paint a house in 3 hours. So we're going to make a table with Joe and Sam. And we're going to write the rate of work, the time it takes them to do it together. Actually, I should have indicated that first. but I'm going to do that, and the part completed. So X is going to be the time it takes them to paint the house together. Okay, so we have the rate, the time, and the part completed. So if Joe can paint the house in 3 hours, the rate of work is going to be 1/3. And if Sam can paint the same house in 5 hours, the rate of work is going to be 1/5. Okay, so together they do it in X hours, and the part completed is going to be for Joe is going to be X thirds, and for Sam is going to be X fifths. So if they combine their efforts, the equation is going to be, let me write this. So we're going to solve the equation. So it's going to be the part done by Joe, that's going to be X over 3, and the part done by Sam. Okay, so let's write that now. So X over 3, that's the part done by Sam. X over 5 is the part done by Joe. And 1, it's one whole job. But that's a linear equation. Okay, so that's a linear equation. So let's solve this equation. X plus 3 over X plus 5 equals 1. Or X plus 3 plus X plus 5 equals 1. So we can either use the least common denominator or simply word the fraction. That fraction is not too bad, but if you still want to avoid fractions, the least common denominator is 15. So multiply both sides by 15. Okay, so 15 times X plus 3, that's 5X. And 15 times X plus 5 is 3X. Okay, so 5X plus 3X is 8X. And X is 15 over 8. Or you write the fraction as a mixed number, that's 1/7/8. Okay, so it is going to take them this fraction or this amount of time to do it together. So it takes them, if they combine their efforts, it takes them 7/8 hours to paint the house together. Okay, now I'm going to finish this video with one more example. So this is a long section, that's why I'm dividing this section into 2 parts. Okay, one printer can do a job twice as fast as another. Working together, both printers can do the job in 2 hours. How long would it take each printer working alone to do the job? So in the last example I did, we knew how long it took each individual to do the job. And we wanted to know how long it would take them to do it together. In this one, we know how long it takes both printers to do the job, and we want to know how long it takes each one to do the job alone. Okay, so we're going to assign names to variables. So we're going to let x be the time it takes the time it takes the faster printer to do the job. To do the job alone. Okay, so 2x, then 2x is the time it takes the slower printer to do the job. So the rates are going to be 1 over x. That's going to be the rate. That's going to be the rate of the faster printer. And 2 over x is going to be the rate of the slower printer. We know that both together, working together, they can do the job in 2 hours. Okay, we're going to make a table like before. We're going to make a table with the rate, the time, and the part of the job completed. Okay, so we have, we're going to make a table, the information for the faster printer and the slower printer. Okay, so we're going to consider the rate, the time, and the part of the job completed. Okay, so the rate of the faster printer is 1 over x. The rate of the slower printer is 2 over x. Actually, that's not 2 over x, that's 1 over 2x. So I'm making a mistake here, that's 1 over 2x. And that one is also 1 over 2x. So working together, it takes them 2 hours. So the part completed are going to be 1 over x times 2 is 2 over x. And 2 times 1 over 2x is going to be 1 over x. So we're going to, if they combine efforts, we're going to solve the equation 2 over x plus 1 over x equals 1. Good thing they have the same denominator, so we don't even need to write the least common denominator. Common denominator is x. So 2 plus 1 over x is going to be 1, or 3 over x is 1. So x must be 3. And that's it. So the faster printer would take 3 hours to do the job alone. And the slower printer would take twice as long. Okay, thank you for listening.